All right, continuing on. So number 17 is where the day 2 notes stuff starts, right? So day 2, this is going to be numbers 17 through, let's see, 31, right? So remember day 2 was linear transformations, okay? So we have to be able to look at a bunch of function. I'm going to move this over here really quick. We're going to look at a bunch of function notation writing, and remember this is how we determine what is happening to the original function, right? Are we shifting it left, up, right, down? Are we affecting this, the slope? Are we reflecting it across an axis? So you need to make sure that you understand those transformations that we wrote on that front page of our notes. All right, so on this one, it says use the linear parent function. Okay, so remember the linear parent function is y equals x. That's the easiest line we can possibly graph. Or we could write that as f of x equals x, because remember f of x is just a fancy way of saying y. So on every single one of these graphs on this page, we're going to be using the parent linear function to do the transformations. So I don't know about you, but I'm going to go ahead and draw my parent linear function, which is just y equals x, right, which means it has a y-intercept of 0 because there's a little understood 0 hanging off the end, and it has a slope of 1 over 1. So I'm going through the origin, and then I'm going up 1 over 1, up 1 over 1, up 1 over 1, right? That is what y equals x looks like. And I'm going to go ahead and sketch him while I'm at it. I'm just going to go ahead and draw him on every single graph, because this is the original line that we are talking about on all 4 of these problems. Remember, it has to go through the origin and have a slope of 1. Okay. All righty. So here we go. And I'm going to, never mind. Okay, so let's go graph the new lines, right? So remember, I know this looks weird and complicated, but it's really not. This is really just giving you a set of instructions. It's basically saying, I'm graphing a new line, and I'm going to call it g of x instead of f of x, because technically this is our f of x, right? That's what that's talking about, because it's the same thing. F of x is the same thing as y. So I'm just going to draw a new line. I'm going to call it g of x, and this over here is just a set of instructions. It's telling you what to do with this line to create our new line g of x, right? So you just have to remember, what does this plus 2 hanging off the end, what does that tell us to do to the line? Right, so hopefully you remember from our little Desmos activity, right, that this means we shift up 2 units. That's it. We're just shifting up 2 units, which means my y-intercept is getting moved up 2. So instead of 0, it's getting moved to positive 2, but my slope is not changing, right? So it's still a slope of up 1 over 1. I'm just taking that entire original line and I'm moving it up 2 spaces. And that is my new line, g of x. Right? I just took the old line, f of x, and I moved it up 2. That's it. Right? You just have to be able to interpret the set of instructions that you're being given. Okay? All right, let's hop over here. G of x, so new line. So here's our f of x right here, but they decided to put a minus 4 in the parentheses. So remember, anything that's plus or minus is always a shift. Right? Anytime you see a plus or minus a number, it's always going to be a shift. So this one is only affecting the x's, so it's clearly a horizontal shift, because remember, when the number's trapped inside with the x, he's only affecting the graph horizontally. Okay, we had this whole chat in class. And remember, it's kind of confusing, because when a number is trapped inside the parentheses, it's actually not his true form yet. So it's always the opposite of what you kind of think is happening. So when you see a minus 4 inside the parentheses, this is actually a shift of right 4. right? It's always the opposite of what you're seeing inside the parentheses. When it's outside the parentheses, what you see is what you get. But when it's on the inside, it's going to be the opposite. So we're going to take this graph and we're going to shift it right 4. So 1, 2, 3, 4. I'm just going to move the intercepts because I think that's easiest. So I'm just going to move my graph over 4 units. And my slope is not being changed. So my slope is still, oh my goodness, what's happening? That was strange. Sorry about that. All right, and so my slope is still 1. So I'm still going up 1 over 1. Voila. Right, and there is my new g of x line. All right, just taking my original f of x line and shifting it right 4. Okay, so again, this was f of x. Okay. All right, moving on to this one. So again, this is my f of x line, because remember, f of x just means y. It's nothing too crazy. All right, now this one is telling us to take the x value and multiply it by 3. So we need to know what the effect of that is. So if you remember our rules, this means the slope, and only the slope, gets multiplied by 3. Or you can say the slope is tripled, right? So remember, right now, I have a slope of 1. Right? My current line has a slope of 1. Well, I want to multiply that by 3. So clearly my new line is going to have a slope of 3. And my y-intercept is not getting affected because it's only trapped inside with the x. So only the slope gets multiplied by 3. So my y-intercept is still 0, but now I'm going up 3 over 1, up 3 over 1, up 3 over 1. Right? So my line is much steeper because my slope got multiplied by a bigger number. And we should be able to connect all those dots. And there we go. Right, and that is our new g of x line, right? Where all we did was took our original line and changed the slope by a multiple of 3. I'll put m equals 3. Okay. All right, and then our last one over here, you'll notice the only difference between the original and what they've done for g of x is this negative multiplier, which is technically a -1. It's a -1 multiplier on the entire f of x, on the entire y, which means this is a reflection over the x-axis. It also means, right, that you're negating, I'm going to write this down. Now on a test, if we ask you what the transformation is, you have to write reflection over the x-axis, right? But what that actually means is the slope and y-intercept are multiplied by -1, right? That's what it means to be a reflection across the x-axis, that the slope and the y-intercept are both getting multiplied by -1. Now our slope is +1 for our current line, so obviously my slope is going to become -1, and his y-intercept is 0, right? Remember, there's a +0. So if I multiply 0 by -1, it's still going to be 0, right? So initially, the only thing that's really changing is that my slope is becoming negative, which means he's going to be a decreasing line. And you'll notice, I don't know why that keeps doing that, sorry. You'll notice that that is a reflection over the x-axis, right? If I were to draw, if I were to draw like a little mirror right here and fold my paper in half along the x-axis, right, these two graphs would lie perfectly on top of one another. Okay. All right, let's go look at perhaps some more complicated ones where our original function is not just y equals x. Because if we always just started with y equals x, then it would be super easy, right? So this one is changing that, and we're now using, sorry, I'm trying to highlight, y equals 6 minus 2x. Now, I don't know about you, but I'm going to rewrite that for everybody as y equals negative 2x plus 6. They have written that with the b in the front and the mx in the back. So I just need you to recognize that that means negative 2x plus 6. So I don't know about you, but I'm going to kind of do what I did on all the other problems before, right? I'm going to go ahead and graph that line everywhere on all 4 of these graphs, okay? So here we go. That means we have a y-intercept of positive 6 and a slope of negative 2, which means down 2, right 1, down 2, right 1, down 2, right 1. God, why does that keep doing that? That's so annoying. Sorry. Oh my gosh. I don't know what my hand is hitting to do that. Oh my gosh. Stop. Yeah, you've got to be kidding me. I'm so sorry. I do not know what's causing that Safari bubble to pop up. Okay. And up 2 over 1, up 2 over 1. There we go. All right. So here is our original f of x function. And I'm going to go ahead and do that on everybody. So just give me a sec, and you do it too. All right. I know it's going to cross through 3, so I can kind of draw it a little bit quicker. Hopefully. I kind of use my guidelines there for that problem. There we go. So these are our original lines, and then we're going to transform them somehow. Okay, then here. Again, feel free to pause the video, give yourself some time, and come back when you're all done if you need to. Okay, so there's my original lines all plotted. Okay, now let's go see what they want us to do to the lines. All right, so this first one is telling us that we have a 1/2 multiplier, but it's happening to the entire function, right? The whole function. So so the slope and y-intercept get multiplied by 1/2 when the number's in front of the whole thing, right? That multiplier is affecting both the slope and the y-intercept. So let's think about that. If our line is y equals negative 2x plus 6, if I half the slope, I'm just going to kind of, there you go. If I half the slope, well, the slope was negative 2, but now it's going to become, oh my gosh, negative 1. Oh my goodness, I do not know what's causing that. It's like only on that little spot. Negative 1x, and then half of my y-intercept, which was 6, it's now going to become 3. So that is the equation of my new line, right? So I'm going to cut my y-intercept in half, which makes perfect sense. So it was 6, but now it's 3. And my slope was negative 2, but now it's negative 1. So I'm just going to go down 1, right 1, down 1, right 1, down 1, right 1. Oh, they share an x-intercept. Interesting. And then down 1, right 1, down 1, right 1, et cetera, et cetera. Get rid of that stupid bubble. And I'm going to try to get that nice and straight. Again, if you're on, it's very important that your lines are perfectly, they don't have to be perfectly drawn, but I will be checking to make sure that they're going through the points they're supposed to be going through. So there are rulers, right, in the baskets on your desk, right, so you can connect your dots and make nice straight lines, right? If you just draw your graph and you're just like, oh, it looks like that, I'm going to take points off if it's not going through the proper points, okay? So use a ruler, right? Nothing wrong with that. All right, let's go. Let me write this a little better. Okay. All right, on number 22. All right, so now it has the negative multiplier on the x, which means this is a reflection over the y-axis. So if you just want to graph that right now, you can literally, here's the y-axis right here, right? That's my mirror, basically. So all the points on this side need to go to that side, and all the points on that side need to go to that side, right? Because you're reflecting it over the y-axis, right? So essentially what that means is, I just like to use the intercepts. So this positive 3 x-intercept, his reflection buddy is over here. All right, so I'm just going to reflect that point, and then I know, oh no, sorry, right? When I reflect it over the y-axis, right, it's going to look like this. And that's my g of x. Now, if that freaks you out because you're like, maybe I don't know how to reflect things properly, that's okay. Remember, what that actually means is the slope gets multiplied by -1. Only the slope, because it's only in there with the x. So if a number is trapped inside with the x, it's only affecting the x value, which is technically the slope because the m is the x, right? The m is the coefficient on the x. So the slope gets multiplied by -1. Well, currently my slope is, and again, you can kind of manipulate your equation if you want to. Remember, our original equation is -2x plus 6. Right? And so we're changing it by multiplying only the slope by a negative. Well, that's going to change it into y equals 2x plus 6, right? The y-intercept is not changing. He's still going to be a positive 6, but the slope gets multiplied by a negative, right? And so if you'd rather manipulate the equation, right, and then graph it, then you can do that. Or if you can reflect a line over the y-axis, then just do that, right? So however far you want to take it is completely up to you. All right, let's go to this guy. F of x plus 3. Okay, well that plus 3 is trapped inside with the x, which means it's affecting the horizontal movement. And remember, we talked about this a second ago. It's always the opposite. So this is a shift left 3. And I can just do that manually. I don't have to do a lot of work here. So if you just take like your intercepts, like I was at +3, but I'm going to go left 3. So now it's going to be here. Right? And you're technically moving all the points right or left 3. So if I take my y-intercept of 6 and I move it left 3, right? So I know it's going to pass through this point. Oh my gosh, the box is back. Right? And so just kind of grab yourself a couple of points and shift them left 3. And again, the slope should be the same. We're not changing the slope. All right, so there's our new g of x. All right, and then our last one, f of x minus 8. So he's on the outside of the parentheses, which means he's affecting the y, which means he must be a shift up or down. And since he's negative, that is a shift down 8. When you're outside the parentheses, what you see is what you get. So -8 means down. So I'm basically taking my y-intercept of 6, and I'm going to move it down 8 units. And my slope is still going to remain -2. So all your points get shifted down 8. It's just easier to just move the y-intercept. But you can pick whatever points you would like. Oh no. Okay, what is happening? Sorry, my iPad screen is being glitchy. Oh my goodness. Sorry, my Apple Pencil is skipping around on me. There we go. And there's our new line that's been shifted down 8. All right, let's move on. Now look at this whole page, right? So on this whole page, we're going to go backwards, right? And we're going to write the function rules that go along with the transformations that have been given, okay? So again, they're saying that we are shifting f of x. So I'm just going to call our new function g of x. You can call it whatever you want. That's totally up to you, okay? So I'm just going to call our new function g of x. So all the way down, I'm just going to write that same thing. G of x equals, g of x equals. All right, so we're going to take f of x. So remember, right now, it's this. If I write this, it's g of x is the same as f of x, right? But we want to move it up 5 units. Okay, I'm going to kind of color code this. If I want up 5, that is a vertical movement, which means we have a plus 5 on the end because we're moving up and down. Then our second thing is we want to make the slope 1/3 as steep. Now the fact that it says slope only means our number needs to be inside the parentheses with the x. So I'm going to do a little scooch in here. I'm going to scooch this over. And I'm going to scooch this over so I can get the 1/3 multiplier in there with the x. And voila. That is going to be the transformation rule for those two events happening. Okay, here we go. G of x again equals, all right, and again, it's kind of like f of x, right? We're taking the f of x and we're doing stuff to it. So here we go. The first thing, left 7. Okay, left, that's a horizontal movement, which means that number needs to be inside the parentheses with the x. So I'm going to scoochie that over. And left 7, remember it's the opposite, so I'm going to put a plus 7 in the parentheses. Then I want to reflect across the y-axis, the x-axis, which means we're negating the y's. Right? If you are reflecting across the x-axis, then it's the y's that are being negated. Again, we talked about this in class. Sorry, I'm going to just explain this again really quick. Right? Remember, if you are reflecting across the x-axis, that means you're taking all the positive y's that exist up here and the negative y's that exist underneath the x-axis, right? And it's the y's that are switching when you reflect over the x-axis, right? So if the y's are switching, that means we need to negate all the y's, which means the negative needs to go in the front. Okay? It needs to be affecting all the y's. If we put it inside the parentheses, we're affecting the x's, and that's not what's happening here. All right, next one, here's our g of x equals, and again, I'm just going to kind of start off with f of x just because I can manipulate it with my iPad. All right, our first one is right 4. Okay, well, remember, right is a horizontal movement, which means I know that 4 needs to be tucked inside the parentheses with the x because the x is the horizontal. And if I'm going right 4, I need the opposite number inside the parentheses. Okay, and then I'm going, let me change colors, up 3. That is a vertical movement. And so that's going to go at the end outside of my parentheses. And you put a plus 3 because when it's outside the parentheses, the number is true to form. I'm just going to scooch that over. And there you have it. All right, next one, g of x equals, I'm just going to go ahead and put my f of x, and I'll manipulate that as I need to. All right, first up, we're going down 2 units. Okay, that's a vertical, so we're affecting the y, so that's a minus 2 on the end. And the second thing is we want to make the slope twice as steep. Okay, well, again, if all you're doing is affecting the slope, that means that number has to go in the parentheses. So the slope is twice as big. So that means, let me grab all this and scoochie it over, because that means I need a 2 multiplier inside with my x. All right, 2 more to go here. So g of x equals, okay, here's my f of x. All right, first up, reflect y, or reflect it across the y-axis. Okay, well, remember, if you're reflecting across the y-axis, then that means, let me just take this little guy. Oh, I accidentally grabbed, hold on. Oh my goodness gracious. Here we go. I'll just move that guy. All right, that means we are negating the x's. All right, and again, we can kind of have that same conversation that we just had above, right? When you're reflecting something over the y-axis, right, there's the y-axis, that means these guys go over here and these guys go over here. Well, what's over here on the left? These are my negative x's. What's on the right? These are my positive x's, right? And so when you reflect over the y-axis, it's the x's that are being negated, right? So that's why we need that negative sign in there. And then we're also shifting up 8 units. So of course that's a vertical movement. So we're going to put a +8 at the end. All right, last one of these, g of x equals, I'm going to put my little f of x. All right, so this one says make the slope and y-intercept 4 times as steep. So remember, if you're affecting the slope and the y-intercept, then that multiplier is going to go in the front of the entire function because you're doing it to everybody. So we need the 4 multiplier to go in front of the entire function, not inside just with the x, because that would only make the slope 4 times as steep. And we want to quadruple everybody. Okay? All right, this next section is kind of weird. This is on your test, so you need to make sure you kind of understand what this is talking about. All right, so it says Riley is buying lunch. If f of x equals 2x plus 7 represents the total cost of his lunch and x is the number of tacos Riley purchased, use a transformation to represent the following situations. Okay, so this one, it's like I said, this is kind of a weird problem. So we know that this whole thing, so all of it represents the total cost, right? So we want to ask ourselves a question. Does this affect, my Apple Pencil is lagging, sorry. Does this affect the total cost, which is y, right? That's the whole function. The whole function itself represents total cost, right? Or is it only affecting the slope, right? And remember, I don't know why I changed colors there, right? The slope is 2, which is basically saying that it's $2 per taco is what that means, right? So he's spending $7 on something else, like a drink and a burrito or whatever. But basically he's spending $7 on something else, but he's adding $2 per taco. So does this affect the total cost or the number of tacos he's buying? Number of tacos, because that's what the x variable represents here. So that's kind of our question here. So when we read all of these prompts right here, we want to ask ourselves, is it affecting the total cost, in which case it's affecting the y, the whole function, or is it only affecting the number of tacos? Okay, so here we go. Let's see if we can understand what's going on here. So part A, Riley has a coupon for $5 off his total. Well, clearly that's affecting total cost. So when I write f of x, right, and I'm not going to change the function. You're not writing a new linear equation. You're writing it in function transformation rule form, like we're doing all up here. Okay, so sorry, what's happening to the f of x if you have a $5 coupon? Well, you're subtracting 5, right? Your cost would lower by $5. Okay, if you want to put a g of x in front, like we were doing, you can totally do that. Okay, so his new cost would be his current total cost minus 5. Okay, we're just putting a real world spin on the same problems that we were just doing up above. Okay, all right. Part B, Riley buys lunch for Lewis. Okay, that means he's got a new total or a new function, costing him an additional $15. Well, is that additional $15, is that total cost, or does that have something to do with the number of tacos? It's clearly the total cost. So now he's going to be adding $15 to his original total cost. All right, letter C, again, new function. Riley has a coupon for 2 free tacos. All right, so if we're only talking about 2 free tacos, that means we're only affecting the number of tacos that he's buying. So that's going to be affecting the x, right? That would not change, right? If that $7 represented him buying a drink and a burrito, right? That wouldn't change. That plus 7 wouldn't change because he got 2 free tacos, right? So basically, if he got 2 free tacos, we have our original f of x, but he's getting 2 free. Now remember, that means he's actually adding 2 to the number of tacos, but when it's in the parentheses, it's the opposite number that you would expect, right? So when we see this minus 2, we're like, oh, that means we went right to, which means 2 free tacos. Okay, again, I know this is kind of weird. All right, last two, g of x. All right, Riley chats up the cashier who takes 50% off his whole order. Well, that's clearly affecting the total cost, so we are multiplying the total cost by 0.5. Or you could write that, because 50% off means he's getting half off, right? So if you'd rather write the 50% as a half instead of a 0.5, I would be totally fine with that. Just make sure you don't leave it as a percentage, right? You need to move the decimal over and write it as a decimal or a fraction because you can't put percentages in math problems. All right, last one, g of x. So in addition to his own lunch, Riley needs to buy an additional 3 tacos for Jackie. Okay. All right, so if he's buying additional tacos, right, that means he's having to pay, right? So up here, let me just reiterate, let me change colors. Up here, he was getting free tacos. So he was just adding 2 tacos without changing his total cost, right? So that's why we were putting it as a plus 2 because they were free tacos. But down here, he has to actually buy the tacos, right? So in this case, it's going to be f of x plus 3, right? Because he is going to have to pay more money for those. Okay. Lost my parentheses there. All right. I know that's kind of strange, but there you have it. And there is a whole section. There's an entire problem on your test that pretty much looks exactly like this one, just with maybe some different numbers and a different scenario, but it's going to be very similar. Okay, so make sure you kind of understand that concept. All right, again, I'm going to stop here because the remaining problems have to do with day 3, so I'll make a separate video for that.